So good afternoon to all of you students. Today we are going to discuss about the connectives. So this video basically covers the three connectives. First one is conjunction, second is disjunction, and then negation. Negation is not basically connective because this is like a unary operator, because it is operated on a single proposition. So let us see. First we will see conjunction, and then disjunction, and then negation. So first is conjunction. So if P and Q are two propositions, P and Q are two propositions, then the conjunction of P and Q, conjunction of P and Q is the compound proposition. As we know, the compound proposition is a proposition which is when two or more propositions are connected using some connectives like conjunction and disjunction and others, then it becomes the compound proposition. So this is the compound proposition denoted as P conjunction Q or P and Q, and read as P and Q. So this is the conjunction. Read as P and Q and denoted as this P conjunction Q or P and Q. And this is P and Q or P and Q is true when both propositions are true. When both the propositions are true, then it is true. Otherwise it is false. So let us see in its truth table. So we can see its truth table. Like suppose here we have taken the proposition P, this is Q, and this is P and Q. Then if this is false, if P is false, Q is false, then P and Q is false. If P is false, Q is true, and this is false. If P is true and Q is false, then again this is false, and when P and Q both are true, then this is true. So we can say this P and Q is true only in one condition, when both the propositions are true, otherwise it will be false. This is also equivalent to the AND operator that we normally study in the digital electronics. So we can say this is the truth table for P and Q. This is truth table for P and Q. Now let us see its example. Example in which we have to form the conjunction for following examples. Let us see the examples. The first example is, suppose the first proposition, that is P is it is hot. The first proposition is it is hot, and the second proposition, that is Q, it is raining outside. It is raining outside. Then we can form its conjunction, that is conjunction of P and Q, as it can be denoted as P and Q. This will be, it is hot and raining outside. Raining outside. So here we are using the AND. So in this way we can form the conjunction for these two propositions, or we can say we can connect these two propositions using this conjunction, this particular connective. Now the second example is, let us say P is 2x plus 3 equals to 7, and Q is, this is x is greater than 1. So these are the two propositions. Now we can connect. So we can write P and Q. This will be 2x plus 3 equals to 7, and x is greater than 1. So in this way we can form the conjunction for this P and Q. And the third example is, let us say P is, Rita is a girl. P is, Rita is a girl, and Q is, John is a boy. Then we can form the conjunction for these two propositions, that is P and Q. Rita is a boy, Rita is a girl, and John is a boy. So in this way we can form the conjunction for different propositions. Now the second connective is disjunction. This disjunction is equivalent to OR operator that we normally study in the digital electronics. Now let us see, first we will see its definition. Then with the help of example we will understand. So again, if suppose P and Q are the two propositions, then if P and Q are two propositions, if P and Q are two propositions, then the disjunction is the compound proposition, is the compound proposition, which can be denoted as P or Q or P disjunction Q, denoted as P or Q, P disjunction Q, and read as P or Q. So this is P or Q. And this will be true, its compound proposition using this disjunction will be true when any of the proposition is true, and this will be false only in one condition, when all the propositions are false. So if here we are taking two propositions, that is P and Q, so this will be true if either of the proposition is true, and this will be false if both the propositions are false. So let us see in its truth table, we can see this is P, Q, and this is P or Q. If P is false, Q is false, this is false. If P is false, Q is true, then this is true. If P is true, this is false, again this is true. And if P is true, Q is also true, then this is also true. So we can say from this table that this P or Q proposition or compound proposition, this will be true using the disjunction when any of the proposition is true, otherwise it is false. So this is false in only in one condition, when both propositions are false, otherwise it is true in these three conditions. So we can say, because here we are taking two propositions, we can also take three propositions like P, Q and R. Then in that also, when P, Q and R all three are false, then it will be false, otherwise it will be true. Now let us see its example. So in this example we have to assign truth value, assign truth value for each of the following. For each of the following. Now let us consider the cases. The case one is if 3 is less than 3 or 4 is less than 6. So here 3 is less than 3 or 4 is less than 6. So this is 3 is less than 3 and this is false. This we can write here, this is false, and 4 is less than 6, this is true. When this is false, this is true, at least one proposition is true, then we can say this will be true. So we can say for this particular example, this will be true. And the second example is, when 3 into 4, this is equals to 21, or 9 plus 7 is 17. So first proposition, this is false because 3 4 ja, it should be 12, but it is 21. So this is false. And 9 plus 7 is it should be 16, but it is 17. So again this is also false. So when both the propositions are false, then we can say this will be false. So its truth value will be false. First one is true because this is false, this is true, hence this is true. This is false, this is false, so this is false. And the third case is, 5 plus 4 equals to 9. 5 plus 4 equals to 9, or 0 is greater than 3. Now we have to assign the truth value for this connection, this compound proposition. So 5 plus 4 is 9, this is true. So 5 plus 4 is 9, this is true. And 0 is greater than 3, this is false. So in this case, when 1 is true, at least one proposition is true, then we can say this will be true. So we can write here, this is also true. So if it is true, it is false, then so in this way we can assign the truth values for each of the following statements. So this is the second connective, that is disjunction. Now let us see the third, that is negation. So negation will be, so the third is, it is negation, and negation is basically, this is equivalent to not operator that we use. So we can say negation of any proposition, let us say P, negation of P is denoted as negation P or not P, like this. So if we are having any proposition, then we can apply this. So this will be the negation, and this will be, moreover we can say, if P is true, then negation P is false, and if P is false, then negation P is true. So this will be true. So we can also understand it with the help of its table. We can make a truth table for it. So if this is P, then its negation is this is P. If this is true, then this is false. If this is false, then this is true. So this is the simple truth table for negation. Now we can take any example. We can take any example. For example, Delhi is the capital of India. If suppose P denotes Delhi is the capital of India, then negation P will be Delhi is not the capital of India. Delhi is not the capital of India. So this is about the third connective, that is negation. So in this video we have seen the three connectives. First is conjunction, second is disjunction, and third is negation. Conjunction is equivalent to the AND operator of digital electronics, and this disjunction is equivalent to the OR operator, and this negation is equivalent to NOT operator. So I hope that you would be benefited from this video. Thank you.